For today's webinar, we are going to cover a modeling of an industrial impeller. So those of you that have been around the scanning industry for a while know that modeling impellers is no new thing. It is one of those types of parts that was like an instant match for 3D scanning and reverse engineering. And impellers have been a thing that we've been asked for, probably one of the most often requested for services or for people that are looking to purchase the software. So many people need to reverse engineer designs like this because there's so many variations and legacy parts out there for this type of object here, and it's highly organic, and it's very difficult to extract the shape any other way. So with that, we'll just jump right over to our next slide here. And you see this one, just taking a little bit of a twist here. I normally see all kinds of turbo impellers or turbine blades or water pump, different types of water pumps that are like internal or closed housings. Those are a lot of the ones that we see most often. So what I wanted to do today is take one that is a semi-open impeller. So this is just a variation design of another one that has some very interesting geometry to it. As you can see, it's a little bit of a different design than you normally see with these different types of impellers. So today I selected this one because it's a variation, it's different, and we will also use it to help talk about the idea of averaging a mesh together too. So we can go ahead and discuss that along the way. So today's is going to be, how would we model this impeller specifically, which is a very similar approach, but as you can see, there are some difficult areas on here that you might have to think about how you would model them. And then the other element is, again, covering how to average meshes together and cover that again as part of this webinar. So with that, we'll go ahead and jump over to the next slide where we talk about the process and then jump into DX. As usual, before we get started with our Design X portion of our webinar, I always like to bring up this slide. I know for some people that watch weekly, this slide can get a little redundant, but we just wanted to make sure that everyone that jumps on the webinar understands the workflow and where Design X fits in here. So as you can see here on the left-hand side, we have different types of 3D scanners, and Design X has the ability to connect to those scanners with plugins and import tools, and we have done it for over 30 years, so we have every kind of importer, file type, plugin imaginable to connect to these different types of 3D scanners. And then Design X is really a CAD platform that utilizes our own scan kernel that we have built from the ground up internally that allows us to handle all that scan data as native entities, bring that in, process it in a way that we can extract model information from it, whether it's CAD model information. Sometimes people want to go straight over to additive, as you can see on the right-hand side. But many times people want to extract CAD model information, both design intent or as built, and send that over to CAD. So by far the top section there is the number one output, where we have a live transfer tool that will allow you to transfer over the CAD information as native entities over to these different CAD platforms. The second one down is we can then save out models like step, IGESat, neutral, all these different native interchange formats to send over straight to CNC packages for cutting stuff directly, or additive. Some additive packages will take CAD models or meshes, and we can save out to those as well. But that's what Design X's overall workflow is to handle that heavy lifting of grabbing scan data, bringing it in, processing it, extracting just the CAD information or 3D model information that you need, and sending it out to the proper output. Now, there's a whole other host of things that you could probably do. These are just the highlights of the different applications that we send out to on a routine basis. So with that, we'll go ahead and jump over to Design X for our presentation. So here is the final product. Just rotate it around and take a look at the part in all of its glory here. And let's go ahead and turn off the solid and turn the mesh on so you can see that. Here is the scan mesh. Now with impellers like this, you have to remember that a lot of times when somebody scans it, it could be a used one. It could be one that failed for some reason. It could be the one made on the Friday before Christmas. There's just so many different things that add into the fact that this geometry could not be the most ideal one to reverse engineer. Or maybe this blade is better than this one. One of these is bad, or what is the best one to use, right? So we have talked about this in the past, but this is one of those pieces of functionality that's very powerful, people love, and we just want to highlight it again and how to go about averaging these blades together. So what I have done is I've taken a minute to cut apart and take just those blades and section them out to then use our average meshes tool. Now, in order to do that, all I did here is I just took this guy and you can use this custom region tool, which is really handy. So when you start drawing, you can see that it's going to indicate to you that it's going to select that top side as you go around. So this is the way I was able to do this. It's just come around. This tool is really powerful, so don't forget about it. It helps select things so much faster. Now you can do this another way, right? Like you can go around and select this geometry. You could duplicate the whole mesh and just delete everything else, and then when you double click here, it will close that shape in, and if I accept it, there's my selection, and I can do a Control C, Control V, and I can copy and paste that. So that's all we did. And then after you do your first round, you can then, it always bothers me having the different color meshes. I kind of want them to be the same. There are times where it might be nice to have them different colors, but I always want to change them back to that default. From there, you can always do a second pass, right? And just come around and select areas and hit delete. And if there are areas you know are a defect like this, come in and get rid of those too. Like these types of things, like that's a defect. I don't want that to average in the rest of it. And you got areas like this. This one, going back to that other tool, is probably the best way, right? You can come around here, hit accept, delete. You can do it that way. You could also use defeature, so I can click on that and hit defeature and have it just remove that area. And you can do these on multiple areas at once. So if I just grab this and that and then hit defeature, both of those are gone. Yeah, and then you can come back with just your whole fill. One thing that people do forget about is that you can do a select all in whole fill and then just deselect the biggest and come back and just let it fill all of them. Now with this one, it had a different algorithm, right? So like it filled that. And remember, you actually, for averaging purposes, not everything has to be filled, right? That's another aspect of this, that I could just leave that open if I want to, and it just will not average in with the rest of them. And, if you wanted to process this, you could come over to Global Remesh A lot of times I'll raise the resolution a little bit and then hit 0.5 and run this. So it will go through and just kind of relax the shape of the mesh, and it reorders the edges of the triangles and things like that to make them cleaner. So you see that? It doesn't, I mean, it edits it by microns, but I like global remesh and then do like a 0.5 or 0.7 somewhere in there. Um, and then you could do that on all these too, just to like clean them up, tune them up a little bit, and then turn that off. So now let's just go jump over to the averaging tool. So let's go ahead and turn the ones that I already had on, the one that I did. We'll run through this tool and show how it works. So if we come over to average meshes, this has changed a little over the years. And I will say simple is better with this tool. Uh, I have broken these out as separate chunks. You can also create regions on an individual part and just click regions to create it. It just depends. And if you struggle with getting these to line up in the tool, which we'll talk about here in a second, you can actually just manually align these using the scan alignment tools and just come in here and not use the pattern and just let it do it that way. Sometimes people like that, and you can visually see which one is furthest out and delete areas that you visually know are wrong and then re-global fit it to the other ones. So, so there is a manual way is what I'm trying to say. If these aren't grossly uh, different, then this tool works great. I mean, it can take stuff that's different, but you'll see what I mean. I'm going to go ahead and select it, and we'll just get into it. So I'm just selecting all those meshes, and I'm going to tell it, you can create an axis ahead of time. I usually do that. This time, we're just going to use it this way because we'll show it a different method. And I'm just going to tell it calculate the axis, and you'll see it update over here. And then you can tell it calculate the center, and it takes it a second, and then it will update. So after that, you can kind of go back again and hit calculate back and forth between these. I say that because you'll see here when we apply the preview. So just click on the preview. This is very helpful rather than running the tool. That's a mistake that I tend to make when I use tools is I just run it and I'm like, there is a preview. You can use it and it can save you undoing and stuff. So I like to run the preview to see what it comes up with first before I run the command. So now it has it. It actually did a pretty good job right out of the gate for me this time. There are times where you can visually see that they're not quite aligned. This is about as good as you're going to get. This one has some issues with it. That's why we're running the average mesh on it. There are times where they'll be way off from each other. And then if it is, you can hit recalculate here, or manually assign one, or you can come back and also hit the max deviation and then run this again over and over to just visually see what you're going to get. This time it worked for me. Now it's going to have a little bit of because this is just so far away, it's going to have a little bit of a thing there on that. I don't know how to describe it, but you'll see what I mean. So there we go. Turn these off. And, sometimes you'll just get some layering and stuff like that, but you can always run global remesh as well on the whole thing before you reverse engineer it. So there we go. We have our averaged mesh, and we can reverse engineer. Now, I will say this specific part, when we actually go run through the history here, we reverse engineered each one individually because they were so far off. I think the customer might have requested, or whoever requested, that you do that separately. So just so you know, I'm showing this, and this is what I would use on this, if we're doing a project. But in this specific rollback, you'll see that it's modeling all three independently. But this is a really good tool for this. So let's go ahead and turn that off. I'll just blow these away just so they don't accidentally mess up something. And we will roll back our history. So turn this on. Actually turn it on. There we go. And roll back. So here we go. We went ahead and created our axis. And there we go. Roll forward. And we revolved the external shape here. So we'll turn on the surfaces. Went ahead and did a revolve of the outer trim line of the entire part. This is kind of like modeling the housing that this is going to go in right out of the get-go, right? So go ahead and model that, and you can see, let's just edit that sketch. See what we did there. I think that shows it better. And you see how we did a revolve silhouette back to a plane so you can get that nice accurate data. That tool is just so valuable to be able to silhouette this entire part back to a plane and then draw the entire silhouette. Other reverse engineering softwares out there, I don't know a good way to do it besides this. So now we'll go ahead and jump forward. And we are, just because it's easier to see here, we're going to do the inside here. So we did a 3D loft. They could have done a loft wizard on this. Yeah, they did a loft wizard with a center line. So draw a center line down and then do a loft wizard on it following a path. So let's go ahead and then we do our typical extend. And then now we're doing the other side and an extend there. Now we're doing an extrude down the end. And a trim surface there. Just go ahead and trim it. Sometimes it's better just to trim stuff in stages like that, because it could be very difficult to do trims all at once. So if you know that this is solid and it's going to trim to that quite easily, go ahead and trim it. Keep it simple. So you see there we're doing the top and bottom on this side and the extrude down again. And the extend and the trim. So let's forward there. So we got that one. Now we're back. I went all the way up to fitting the front and back and extend of this one. And the extrude down and the trimmy trim. Okay, so I did that final trim there too, where we trimmed everything, all of those to the top. So now if I hide that, you see that we got our blades. Now we go to revolve the base as a solid. So we'll go ahead and turn that on. So if we hide that real quick and see it, that was a nice constant rotational that now has a cutaway. So we'll go ahead and create this block. So they just decided to cut the bottom of these guys. So what we did here is, if I hide the surfaces, no, there we go, surfaces, taking that cut, we're able to cut with that tool, and the remaining bodies here are the blades. So it was a way of like solidifying. There's a whole host of ways that you could have done that, but that's an interesting idea where they just extruded that box and then did a cut with the surfaces and then kept the other side, right? That's what they did. So this was a giant solid box, and they used that surface to cut and then keep the inside. So now, roll forward, and before we merge these teeth in, or blades, we're going to go ahead and cut that outer shape from the rotational impeller, and go ahead and add the full face fillets to each of the blades, then merge those with the base and apply the fillets. So this is really neat. Just put a massive fillet right there. That will work. And it's more of an idealized way right there. That's probably what it was. So you see here, if I just turn the mesh off, now apply fillets to the bottom of the blades, and that just looks gorgeous there. And we'll jump forward and add the keyway and the holes, and we're going to cut the ends right there. Cut those ends off the sides, and there we go. We have the final product. You can even spin it on screen if you need to. There we go. And then turn on the accuracy analyzer, and you see this happens with these types of parts, these castings and that are machined and stuff. There's lots of deviation. There's deviation for reasons that it could be a used one, like we talked about before. It could be the part made on the Friday before Christmas. It could be that this was a failed one, that failed inspection, was thrown in a corner. Who knows? And now we're scanning it because we don't have anything else to scan. There's lots of different reasons why there's a lot of variation in these parts. And what Design X is allowing you to do is to follow it or not follow it, and then compare back to it to understand how closely you did follow it or not follow it. That way you can just quantify the deviation. So you can see I can roll over the surface of it with my mouse and understand the deviation underneath that specific location, and being able to check that and check your reverse engineering process. So yeah, today was a little bit shorter, but I think it was valuable. We talked about averaging the blades together, and then modeling a really neat impeller, which is a popular thing to do inside of Design X.